Okay, so let's talk about a function when we don't represent it as an equation like we did in the last video, but in this one we're going to talk about what happens if we represent a function as a graph. Right? So we're still talking about inverses and switching domain and range. The big idea hasn't changed, but now we're going to be inverting it using its graph instead of its equation. So here's a big idea that we discussed a little bit in the last video. If you remember in the last video we said that when we take the inverse of a function, what we get, the new function, the new thing that we're calling the inverse, is not always going to be a function. And so we want a way that we can check to see if something's a function. So if you remember, several times in Algebra 1 and in Algebra 2 and even before that, you had talked about the vertical line test. And so what the vertical line test said was that if you draw a vertical line down any graph and it passes the vertical line test, which means that the graph only ever hits the line only ever hits the graph at one spot, then you have a function. Okay, so now we're going to say, well, okay, if it passes the vertical line test, then it's a function. We're adding something new, and we're saying if it passes the horizontal line test, then it's what's called a one-to-one function. So let's just kind of like take a look at a little example here. Right? If I were to draw this graph right here, this is a parabola. Okay, we would say that this function, if I were to draw a vertical line anywhere I wanted, it's going to pass the vertical line test. I'm only ever hitting the graph one time. So I'm saying, you know what? Parabolas are functions because they pass the vertical line test. Okay. So if I were to say instead, is this function a one-to-one function, right? If a function is one-to-one, then it should pass the horizontal line test. If I were to draw a horizontal line through a parabola, it does not pass because I'm actually hitting the parabola in two different spots, right? So in this case, I would say this parabola is a function, but it is not more specifically a one-to-one function. Okay? And here's why we care about that. If a function is a one-to-one function, then when we take its inverse, okay, the result, the new thing, will also be a function. In this case, if I were to take the inverse of a parabola, I am going to get something that is not a function because it's failing the horizontal line test. Okay, so this is our quick way to check to see if a function's inverse will also be a function. And in this case, the answer is no, because it fails the vertical line test. If you want to see one that works, if I were to graph, for example, just a straight line, right, like that, and I were to check the vertical line test, again, vertical line test, I'm good, right? I can pretend like those are vertical lines, right? My lines aren't coming out straight up and down. Right, if I were to say there's a vertical line, I can draw that line anywhere I want, and it's going to only hit my graph one time. Okay? If I were to try to draw a horizontal line, same thing, right? I can draw this horizontal line wherever I want, and it's only going to hit my graph once. So I would say a linear equation, right, a line, okay, is a one-to-one function because it passes the horizontal line test. Okay? So that's a way of checking. If I say, is the inverse of this function also a function, you're going to use the horizontal line test. Okay? So that's the first big part, determining whether my new inverse is a function as well. Here's the second part. Oh, well, let's look at some examples. Right? So if I were to take a look at these examples and say, is the inverse of this function also a function? Well, here's our parabola. We already talked about that one. In this case, we're going to say if I draw a horizontal line through it, it does not pass the horizontal line test, in which case we're going to say this is not one-to-one, so its inverse is not a function. So the answer to this one, we're going to say we're going to say f of negative 1. Oh, let me write that correctly. F of negative 1, which is, again, the way that we write the inverse notation, not a function. Okay. And I could also say, if I want to describe this function, this parabola, I would say this parabola is not a one-to-one function. That's the connection. When the parabola is not a one-to-one function, its inverse will not be a function at all. Okay? So this second one's maybe a little bit deceiving. We have to be careful. This line right here is subtly going up. So in this case, I'm going to say draw your horizontal line wherever you want, right? Even in this spot right here, I'm saying it's only actually hitting probably right there. It's like missing this a little bit above. So I'm going to say this function right here, which is a cubic function, its inverse is a function because this is one-to-one. So I'm going to say in this case, f inverse of x is a function because it passes the horizontal line test, right? And this one right here, I believe this is a sine function, right? If I were to draw this one, it's very obvious that it's not going to pass the horizontal line test. Oh, yeah, there it says right there, sine function, okay? So this is a sine function, which we'll talk about in trig and maybe later this year. But we're going to say this fails the horizontal line test at a lot of different spots, right? All these spots are hitting the same horizontal line, and this actually continues on. So we're going to say that in this case, f inverse of x is not a function. And again, I could say that means that another way of stating that same fact, that f inverse is not a function, is to say that this is not a one-to-one function. Okay, so that's the big idea right there, is let's make sure we can describe what the inverse looks like and how it's going to act. Okay, here's the other part. If I actually ask you to graph the inverse of a function, we don't have to take the algebra, switch x and y, resolve it, get a new function, and then graph the new one. Instead, what we can do is just switch all of the points. Okay, so watch what happens here. I'm saying in the words up top, the graph of the inverse is where all of the points that from f that I wrote as x, y, you're just going to switch the x and the y for every point. So here's a simple example. Okay, if I were to take the function 2x plus 1, okay, and I said, okay, let's just make a quick xy table. Okay, these are some points that are on 2x plus 1. Let's just do -2, -1, 0, 1, 2. Okay, if I were to graph these, or if I were to plug these in, I would say this is 2 times -2 is -4, -4 plus 1, -3. Right, and we can keep going through these. This is, okay, I'm sorry, that's -3. And this is -2 plus 1, which is -1. 0 is a 1. When I plug in a 1, I get a 3, and when I plug in a 2, I get a 5, right? So I'm just plugging in x to get y. So let's graph these real quick. If I want to go over to -2 down to -3, that's a point. -1, -1, okay? 0, 1, 1 up to 3, and 2 up to 5, and I got myself a nice line here. Let's see if I can draw a nice line. Okay, there we go. Okay, so I got myself a nice linear equation, which I should get because we know 2x plus 1 should make a line. Okay, so that's the graph of 2x plus 1. I'm good. If I want to draw its inverse, here's the new table. I don't even need to plug in. I don't need to like find out what the equation's going to be when I switch x and y. All I need to do is take my original xy table. Okay, let's take this xy table and switch all of the x's and y's. So I'm going to say instead -3, -2. This one you can't see because I'm switching two negative ones. Right, so I'm taking all of the x's and y's and I'm switching them. And that fits the definition of what an inverse is. We said an inverse is where the domain and the range switch. Okay, so let's take a look at the graph of this one. So this is going to be -3, -2. Okay, -1, -1 is actually the same. 1, 0, 3 up to 1, and 5 up to 2. Here's my new graph. Okay, so I'm going to say this graph right here represents the inverse. So I could say this is f of x. Okay, this is f inverse of x. Okay, and so here's something I want you to notice before we end the video. Okay, if I were to draw a line, I'm going to make a nice dotted line here. Let me get my dotted line tool. Okay, if I were to draw the dotted line right down from like the diagonal of the graph, right, from this corner right here, right down the middle of the graph to the other corner, okay, these graphs are actually reflections of each other, right over that line. This is the line y equals x. Okay, so I've actually reflected all of my points right over that. If you notice like how far away that point is, the other one's the same distance but on the other side, and that's what a reflection is. If I were to check each of them, right, little bit away, about 1 box away. This is about half a box away, half a box away. 1's actually right on it, and again I got this half a box away, half a box away. So each of my points is an exact reflection right over the line y equals x, and that makes sense because we actually just switched y and x. Okay, so that's a way you can verify that your graph is correct. You can look at your new graph and your original function and say, is it a reflection over a dotted line, the diagonal dotted line y is equal to x. Okay, so that's just a check for you. But to do the actual graphing of any of these points, we can just switch x and y and graph our new equation.